In this segment, we'll talk about round-off errors. So in order to talk about round-off errors, what we need to do is we need to talk about where the errors come from in computation. So we're talking about the errors which are inherent in numerical methods. So the two types of errors which are inherent in numerical methods, one is the round-off error and another one is the truncation error. And it's important that we understand the distinction between the two because sometimes they get conflated with each other. So round-off error comes from caused by approximating numbers. Because if we cannot take a number and represent it exactly, it will have to be represented by an approximate number. That's where the round-off error comes from. Truncation error, which is a separate lesson, comes from approximating mathematical processes. So it's important for you to understand that, hey, we have round-off error here, which is caused simply by approximating numbers. So round-off error is defined as actual number and from that you subtract the representation of number. So a good example of that is 1/3. Let's suppose 1/3, we know that if you write it in decimal format, it will be written like this. Now if we say, hey, we want to represent 1/3 with only 6 significant digits, let's suppose, then this will be the approximation of 1/3. So if that's how it is represented, then the round-off error will be 1/3 minus this number right here. And that number will turn out to be, we have 6 zeros right here, and then we'll have 3, 3, 3 recurring from there. So that's how the round-off error is taking place. Now, round-off error also takes place in irrational numbers such as pi, square root of 2, and so on and so forth as well. That's to be thought about. Also, what you got to think about is that since numbers are not represented in base 10 in a computer, they are represented in base 2. So let's suppose I have 0.3 in base 10. This number here will have infinite number of zeros and ones, 0 or 1s, after the radix point right here. So what that means is since the computer represents in base 2 and 0.3 cannot be written exactly in base 2, it will require infinite number of digits after the radix point. You can very well see then, since the computer cannot have infinite number of bits to represent the number, there is going to be a difference between how 0.3 is represented actually in the computer. So there's going to be a difference, and that will be the round-off error also. Also, for round-off error, you got to think about two things. Are you chopping a number, or are you rounding the number? So that's something which you will see in later lessons as well. Chopping is where, for example, if you have a number like 0.3378 and somebody says, hey, go ahead and write it up to 3 significant digits, you will write it as 0.333. That is chopping. If somebody says, hey, go ahead and use rounding, you will say 0.334 because this digit here is 5 or more. So that's why you will, there's a difference between these two things, chopping and rounding. But the error which is caused by chopping or rounding is still called the round-off error. And that's the end of this segment.